Hey guys, so I wanted to work out some extra problems for you on 17.2 just to give you maybe a little more help, work out some problems from the book so that these will be just like the problems that you have in your assignment. And if you're having some trouble, watch this video and that'll give you some additional examples. So what we want to start out with is our unit circle. Okay, this is a circle centered around the origin, 0, 0. And has a point at 1, 0. This one is at 0, 0, 1. This point is at -1, 0. And this point is at 0, -1. We'll be working with SOHCAHTOA, sine, cosine, tangent. SOHCAHTOA, sine of an angle, theta is an angle, equals opposite over hypotenuse. Ca means cosine of our angle equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. So this should be familiar to you from SOHCAHTOA, from geometry. The new part is the unit circle. So if we just took, well, let's see here. A really good exercise for you to do is to fill in all the angles on a unit circle. We always start from this side. And we work our way around this way. And when we think about the unit circle, well, we can divide it into 4 pieces, four quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And each quadrant we can divide, we can draw 3 angles on. One, of course, is the halfway, and that's 45 degrees. Okay, I'm going to write the 45 out here because it'll get a little confusing if I keep drawing things in there. 45 degrees, that's halfway. So we'd have another one of those out here, and that would be 90 degrees plus 45, 135 degrees. Over here, starting from here, going out to here is 180 degrees. This will be 180 plus 45, 225 degrees. Down here will be 270 degrees because that's 180 degrees plus 90 degrees. And when we go 270 degrees, well, let's do the halfway thing here. It's 270 plus 45, so that will be 315. 315 degrees. Add another 45 degrees and we get to 360. And that's the same as 0 degrees. We can also divide these into 30-degree chunks, and that fits nicely. It'll go into 90 degrees. So So this angle would be 30 degrees. Add another 30 degrees, we'd get to 60 degrees. Then 90. Keep going by 30 degrees. We get to 120. And we get 150. We can do the same over here. 180 plus 30 degrees is 210. 210 plus 30 is 240. And 240 plus 30 is 270, so that works out right. And we can keep adding 30. 270 plus 30 is 300. And 300 plus 30 is 330. So these are all the different angles that we're going to be working with on the unit circle. There's, of course, infinitely many angles, but these are the important ones and the significant ones we're going to be looking at. Okay, so we also introduced something called radians. And a radian, if we think about what a, let me just take a look here. We learned about radians in 17.1. That's how many times a radius, this length, will fit around the circle, and it'll fit 2 pi times, which is 6, about 6 plus a little bit more times around the circle. So if it fits around the whole circle 2 pi times, it's going to fit around half the circle pi times. It's going to fit around 90 degrees, well, half of pi over 2. And it's going to fit around 3/4 of the circle. 3 pi over 2. That's 1.5. And we can also fill in our radian measures for each of these angles all around. If we wanted to do that, I'll show you how to get started, but I won't do it all for you in this video. We take pi halves. That's 90 degrees. And we have this piece here, this piece here, and this piece here. Those are 30-degree chunks. And we can see that 3 of them fit in this section. So we're going to take pi over 2 and divide it by 3. This is the same as pi over 2 multiplied by 1/3. And that equals pi over 6. So this is going to be 30 degrees is equivalent to pi over 6. We go to our next, angle up, and that'll be pi over 6 plus pi over 6. And that'll be 2 pi over 6, and that simplifies to 1 pi over 3, or just pi over 3. So this angle is 60 degrees is pi over 3. And what about that 45 degrees there? Well, 45 degrees is half of 90 degrees. So it's half of pi over 2. That's the same angle as 90 degrees, so we're just going to divide it by 2. When we divide by a fraction, we multiply by the reciprocal, and this will be pi over 4. It's getting a little messy over there. But I think you're getting the picture. I'll let you work out what these will be in radians, but these are the kinds of things that we're working with in this lesson. So I hope that that's making sense to you. In this lesson, we are asked, without using a calculator, find the cosine of 135 degrees. So what we do is, I'm going to draw another unit circle here. 135 is halfway between 180 and 90 degrees. So our angle starts here and it ends here. It's a 135 degree angle. We're asked to find the cosine of 135 degrees. And we do this by finding the spot where our angle hits the unit circle, and if we draw a line straight down, we'll find we can make a triangle, a right triangle. And this is the triangle that we're interested in. Even though the angle is 135 out here, this triangle will help us find out what the cosine of 135 will be. And we actually use this angle, this triangle, to figure this out. It's kind of confusing, but this is how we do it. This is a 45, 90 degree triangle. And this is a unit circle, so our hypotenuse is 1. And we worked it out in our last video. We have root 2 over 2. If you're not sure why it's root 2 over 2, I encourage you to figure this out. Call each of these A, because they're going to be the same. It's an isosceles right triangle, so these two side lengths will be the same. This is 1. Do a squared plus a squared equals 1 and solve for a. And you'll get this. You might get you might get 1 over root 2, and that's actually the same thing as this. Multiply the top and the bottom by the square root of 2, and it'll work out. Okay, so I'm going to assume that you're with me on square root 2 over 2 is the lengths of the sides. And we're asked to find the cosine. Cosine is adjacent over hypotenuse. So this is our angle we're going to be using now, 45 degrees, this one that completes the circle there, half triangle there, half circle, excuse me. What about this one here? Cosine of 135 is adjacent over hypotenuse. Adjacent is root 2 over 2, and hypotenuse is 1. So this equals root 2 over 2 divided by 1. And this equals square root 2 over 2. So that's how we find the cosine of 135 degrees. Do your unit circle. Start with your initial side over here on the x-axis. Draw your 135 degree angle. Drop the angle where it connects to the circle down to the x-axis, even if that means it's outside of the angle. That's fine. If it's on the outside, that's okay. And now we have a 45, 45, 90 triangle. We figured out our side lengths are root 2 over 2. We knew that was true from a 45, 45, 90 triangle. And then we just used our SOHCAHTOA. We're doing cosine. Cosine is adjacent over hypotenuse. That's where these values came from. And we can see divided by 1 doesn't change anything. That just equals root 2 over 2. So that's how we find cosine of 135. Okay, let's do another